On July 1st, 2025, a ground-based survey telescope in Chile called ATLAS, built specifically to scan the sky for objects that could threaten Earth, flagged a faint point of light moving in a way nothing native to our solar system moves. Within days, astronomers confirmed what the trajectory was telling them. This object was not orbiting the Sun. It had arrived from somewhere else entirely, traveling on a path so extreme, so hyperbolic, that it could only have originated outside our solar system altogether, and it was simply passing through. It became known as 3I Atlas, only the third interstellar object ever confirmed in human history, and over the following year, NASA turned nearly every major instrument it had, Hubble, Webb, TESS, SphereX, even the Mars Reconnaissance Orbiter, toward this single fast-moving visitor before it disappeared back into deep space for good. What those instruments found is genuinely one of the strangest, most scientifically rich data sets ever collected on a single small body. Real chemistry unlike anything in our own solar system's comets. A jet of material pointed in a direction that shouldn't be physically possible under standard cometary behavior, and a level of public fascination substantial enough that NASA itself has had to formally and repeatedly address speculation that this object might be something other than natural. This script is going to walk through what 3I Atlas actually is, what the real data from Webb and Hubble actually shows, why some of that data has become genuinely controversial among scientists, and where the far more speculative alien technology claims came from, and why the overwhelming scientific consensus does not support them. All of it is real. None of it needs exaggeration. Start with why an interstellar object is such a rare thing to even find. Everything that normally orbits our sun, planets, asteroids, comets, was born here, formed billions of years ago out of the same swirling disk of gas and dust that became the solar system itself. An interstellar object is fundamentally different. It formed around another star entirely in another planetary system and was later ejected, most likely flung outward by a gravitational interaction with a giant planet in its home system, sent drifting through the galaxy for potentially billions of years before, by sheer chance, its path intersected ours. The first confirmed interstellar object, Oumuamua, was spotted in 2017 and left astronomers with more questions than answers, largely because it was discovered too late in its passage for detailed study. The second, Borisov, arrived in 2019 and behaved much like an ordinary comet. 3I Atlas is the third, and unlike its predecessors, it was caught early enough and is bright enough for the most powerful telescopes humanity has ever built to study it in genuine detail. Its orbit alone tells you it does not belong here. Astronomers measured its incoming trajectory with an eccentricity of just over 6, where any value greater than 1 indicates an orbit that is not bound to the Sun at all, meaning the object is not looping around on a long ellipse the way a normal comet does. It is passing through once and will never return. Its velocity, projected to what it would be at infinite distance from the Sun, works out to nearly 58 kilometers per second, among the fastest of any object ever tracked through the solar system. Combine the speed with the orbit's geometry, and you get an object confirmed without meaningful scientific dispute to have originated from beyond our solar system entirely. Now, to what the James Webb Space Telescope actually found when it turned its infrared spectrograph on 3I Atlas in August of 2025, while the object was still roughly 3 times farther from the Sun than Earth is. Using an instrument called NIRSpec, Webb captured a detailed chemical spectrum of the coma, the cloud of gas and dust that develops around a comet-like object as sunlight warms its surface and drives material to sublimate directly from ice into vapor. What Webb found was a coma overwhelmingly dominated by carbon dioxide, with a ratio of carbon dioxide to water measured at roughly 7.6 to 1, among the highest such ratios ever recorded in any comet, solar system or otherwise, and researchers noted the measurement sat more than 4 standard deviations above the typical trend seen in comets native to our own solar system at a comparable distance from the Sun. Water, carbon monoxide, water ice, dust, and a tentative trace of a sulfur-bearing compound called carbonyl sulfide rounded out the detected chemistry, painting a picture of an object whose ices appear to have been shaped by a very different and possibly much colder or more radiation-exposed environment than anything that formed our own solar system's comets. Follow-up observations pushed the chemical picture further. As 3I Atlas passed closest to the Sun in late October of 2025 and began moving back outward, Webb's mid-infrared instrument, MIRI, captured additional spectra in December of that year, this time detecting methane alongside the water and carbon dioxide already identified, along with a faint but genuine spectral signature of nickel. Nickel detections in cometary comas are themselves unusual and have only recently become a subject of active study in solar system comets as well, typically appearing without a correspondingly strong iron signal. A chemical imbalance researchers are still working to fully explain in objects from our own solar system, let alone one from another star entirely. Separately, ground-based spectroscopy using the European Southern Observatory's Very Large Telescope measured specific isotopic ratios of carbon and nitrogen in the comet's cyanide emissions, data that researchers described as directly relevant to understanding prebiotic chemistry, the basic chemical building blocks relevant to life elsewhere in the galaxy, not evidence of life itself, but a genuine data point in the much larger question of how common or rare the raw ingredients for it might be across different star systems. Separately from Webb's chemistry, Hubble's imaging turned up something structurally strange enough that it has become a genuine subject of ongoing scientific analysis. Beginning with Hubble's first observations in July of 2025 and continuing through imaging taken in January of 2026, astronomers identified a persistent jet of material extending from the comet's nucleus in the sunward direction toward the sun rather than away from it. This matters because standard cometary physics predicts the opposite. Solar radiation pressure and the outward flow of the solar wind should push a comet's dust and gas tail away from the sun. The reason comet tails almost universally point outward, regardless of which direction the comet itself is traveling. A jet oriented toward the sun, called an anti-tail, is not entirely unheard of in solar system comets under specific viewing geometries, but the persistence and structure of this particular feature, described in detailed analysis as extending outward to a scale of roughly 400,000 kilometers and showing a triple jet substructure in later imaging, has made it a genuinely active subject of study and disagreement amongst our researchers, trying to model exactly what physical process is producing it. The size of the object itself became its own point of scientific back and forth early. Estimates of the nucleus, the solid core, hidden beneath the glowing coma, ranged widely depending on which assumptions a given research team used about the surface's reflectivity, since a telescope can only measure total brightness and has to infer size, by assuming how much of that light is being reflected versus how dark the surface actually is. Some early analyses, including estimates, low published, argued for an unusually large nucleus, potentially tens of kilometers across, dramatically bigger than either of the two previous confirmed interstellar objects. Other research teams, using different reflectivity assumptions grounded in typical cometary surface properties, argued for a substantially smaller nucleus consistent with an unusually active but otherwise more ordinary-sized comet. That disagreement matters. Scientifically, because size feeds directly into estimates of the object's total mass, its outgassing rate per unit of surface area, and ultimately, how unusual its behavior really is once properly normalized. As more data accumulated through late 2025 and into 2026, the consensus estimate settled toward the smaller end of the original range, though the debate itself is a useful window into how much genuine uncertainty exists even in something as seemingly basic as a comet's physical size when you can only observe it from tens of millions of miles away. Multiple other NASA missions contributed their own piece of the picture beyond Webb and Hubble. The Mars Reconnaissance Orbiter, using its high-resolution HiRISE camera, captured images of 3I Atlas in October of 2025 while the comet was passing at a distance of about 19 million miles from Mars, offering a viewing angle and proximity no Earth-based or Earth-orbiting instrument could match at that particular moment in the object's trajectory. NASA's exoplanet-hunting TESS spacecraft, not designed for this kind of target at all, was repurposed for a dedicated observation campaign in January of 2026, specifically to study the comet's activity and rotation, compiling its images into a short video showing the object as a bright, moving point of light trailing a visible tail. And the infrared mission SphereX contributed its own composition data during a December 2025 observing campaign, measuring the infrared light emitted by dust, water, organic molecules, and carbon dioxide within the coma, adding another independent line of evidence to the chemical picture Webb had already begun building. This is the point in the story where it becomes important to talk directly about Avi Loeb, because his name shows up constantly in coverage of 3I Atlas, and understanding his actual role clarifies rather than muddies the science. Loeb is a real, credentialed astrophysicist, formerly the chair of Harvard's astronomy department, and he has built a public profile over the past several years, arguing that scientists should take the hypothesis of extraterrestrial technology seriously enough to actively test for it when analyzing anomalous objects, rather than dismissing the possibility outright. He made similar arguments about Oumuamua in 2017, but again he has applied the same framework to 3I Atlas, publishing frequent, detailed technical analyses of the object's anomalies, including the sunward jet, its unusually large estimated nucleus size, and its high carbon dioxide content, and explicitly noting that these features, while each individually explainable through natural processes, collectively warrant continued rigorous investigation rather than premature dismissal. It is important to be precise about what Loeb has and has not claimed. He has not asserted that 3I Atlas is confirmed to be artificial. His actual position, stated repeatedly in his own writing, is methodological, that scientists should not rule out the technological hypothesis without evidence specifically capable of ruling it out, and that unusual features deserve the same rigorous quantitative scrutiny regardless of which explanation they might ultimately support. That is a meaningfully different claim than the one that ended up circulating widely in less careful coverage and on social media, where nuance collapsed into outright assertions that NASA had found an alien spacecraft. That circulation became significant enough that NASA felt it necessary to address it directly and repeatedly in briefings, public statements, and its own dedicated 3I Atlas webpage, stating plainly that the overwhelming body of observational evidence, the chemistry, the outgassing behavior, the dust production, the imaging, is fully consistent with 3I Atlas being a natural comet, just one that originated around a different star, and therefore carries a genuinely different chemical fingerprint than anything native to our own solar system. The vast majority of researchers actively publishing peer-reviewed analysis of the object across multiple independent teams using Webb, Hubble, ground-based telescopes, and radio observatories have reached the same conclusion, that 3I Atlas behaves like an unusually large, unusually carbon dioxide rich, but ultimately natural interstellar comet, its anomalies stemming from having formed in a genuinely different environment around a different star, not from artificial origin. The honest scientific summary sits exactly where good science usually sits, which is no tea as dramatic as either extreme framing suggests, but genuinely fascinating on its own terms. 3IR Atlas is real. Its interstellar origin is not in question. Its chemistry is measurably, significantly different from every comet ever studied that formed in our own solar system. That difference is scientifically valuable precisely because it gives researchers their first detailed look at the raw ice and dust chemistry of a planet or Y system that is not our own. Its sunward jet remains an actively studied anomaly, with several competing physical explanations still being tested against the data rather than one confirmed answer. And the extraterrestrial technology hypothesis, while raised by a credentialed scientist using a stated methodological argument rather than a claim of confirmed evidence, remains a minority position not supported by the consensus reading of the same data everyone is looking at, a consensus NASA has stated clearly and repeatedly. By the time you are watching this, 3I Atlas has already passed its closest approach to Earth, which occurred in December of 2025 at a distance of roughly 170 million miles, never posing any collision risk whatsoever, and it is now heading back out of the solar system permanently, fading with each passing month as it retreats to the interstellar distances it came from. Observations through the middle of 2026 continued from Hubble, ground-based observatories, and Mars-orbiting spacecraft as the object crossed the outer solar system, each new dataset adding detail to the chemical and structural picture before this particular visitor becomes forever too faint and too distant to study again. Astronomers do not expect to see this specific object return. Interstellar visitors, by definition, pass through once. What they do expect, based on how quickly detection capability has improved between Oumuamua in 2017 and 3I Atlas in 2025, is more of these objects, arriving more frequently and caught earlier. As next-generation survey telescopes like the Vera Rubin Observatory come fully online and begin systematically scanning the sky for exactly this kind of fast-moving, unbound visitor. 3I Atlas will very likely not be the most thoroughly studied interstellar object for long. It is, right now, simply the best one we have ever gotten a close, detailed, instrument-rich look at, and the real chemistry it delivered is a genuinely bigger story than any invented one could be. It is worth closing on why that matters beyond the immediate curiosity of one strange comet. Every planetary system in the galaxy builds its worlds out of the same basic physics, gravity, gas, and dust collapsing around a young star, but the specific chemica L ingredients available in that dust can differ enormously depending on where and when a given star formed within the galaxy. 3I Atlas carried, frozen inside it, an actual physical sample of that process from an entirely different stellar neighborhood, chemistry that had been locked in ice since long before our own sun ignited in some cases. That is the genuinely remarkable part of this story, not a mystery to be decoded, but a direct chemical letter from another solar system, delivered by accident, studied in real time, by instruments built specifically for exactly this kind of opportunity. Astronomers do not get many chances to sample another star system's raw material without leaving Earth at all. 3I Atlas handed them one, and the data is still being analyzed today. If you want to know what the next interstellar visitor turns out to be made of, subscribe and keep notifications on, because after 3I Atlas, Astronomers are actively looking for it, and this time they will likely see it coming even sooner.